Hey everybody, Mr. Piercy here, and what we're going to be taking a look at in this video is how to find the area of a circle and how to find part of a circle, which would be referred to as a sector. So circles are something that most people are very familiar with from a very early age, but there's certain things that you may or may not have done with circles before. Well, what we're going to be looking at here is how we find the area of a circle, find the area of the sector, how we keep the area as an exact answer in terms of pi, and what the approximate answers will be. So a circle, is the set of all points in two dimensions that are the same distance around, away from a fixed point. And the sector of a circle is it's kind of like a slice of pizza or a piece of pie. It's the portion of the circle that's contained within the two radii. So every time I make a sector in a circle, it's going to be divided up into the minor sector and the major sector. Most people have a tendency to think of the sector of a circle as the minor sector, but when you divide it up into even one sector, there's going to be two parts of it, a minor one and a major one. So maybe you have known for a while what the formula for area of a circle is. It's pi times the radius squared. But one of the things I want to make sure all of my students get exposure to is not just what the formula is, but where did the formula come from? Why is it pi r squared? Well, I'm not going to be able to do a perfectly good investigation for this, but essentially, if you take a circle and you divide it up into a bunch of sectors, kind of like, you take a piece of pizza or take a pizza, cut it up into slices, and you kind of arrange them into what you see here is kind of like this parallelogram looking shape. Well, essentially what you would do is if you were able to divide the sectors of a circle up to the point where they're infinitely thin, they would essentially form a rectangle. So let me just kind of add a rectangular shape here. So we could take that triangle and, oh, and that's a square. I don't want a square. I want a rectangle. Go away, square. All right, so let's try this again. Rectangle. There we go. Okay. Well, so what we're going to do is we would kind of divide those wedges up until they're kind of, we would divide them up until they're, ooh, don't move that, move this one. Until they're kind of infinitely thin, and we would be able to kind of contain them in a rectangular shape. All right, well, I can just move that one, I guess. But the height of the rectangle that would be formed would be the radius of the circle. And the base of the rectangle, if we took this circle here and we laid it out, we cut it apart and we laid it out flat, the circumference of the circle would actually be twice as long as what this side of the parallelogram is. So since the circumference is equal to 2 times pi times the radius, if I take half of that, what I'm left with is just pi times the radius. Well, that pi times the radius, that pi times the radius becomes the side of the rectangle. And of course, the area of a rectangle is length times width, or base times height. So that gives us pi times the radius, which is pi times the radius squared. And that's where the formula for the area of the circle comes from. That's not the only way that you could prove the area of a circle. That's just the most basic, simple way that I could kind of show you in this video. So now that we know what the formula for area of a circle is, we're going to use it to try and find the area of a circle or find part of the circle, like what would be the diameter, what would be the radius, things like that. So here in figure A, we're given a circle, we want to find the area of the circle, given the radius of 4.2 meters. So we're going to just kind of plug them in, plug and chug and see what we get. So 4.2 for pi, I'm sorry for the radius, and 4.2 squared is 17.64 pi. So that 17.64 pi meters squared, that would be the exact area of the circle. So again, for kind of an academic setting, in a math classroom, or if you're doing, if you become a mathematician and you're trying to be exact, those are the things that we would be looking for as far as our answers are concerned. Now, realistically, again, if you're trying to say paint or cover a circle and you need to buy so much material, well then we definitely want more real world stuff would be where we're going to be taking the approximate answer, which would be about 55.4 meters squared. Now of course if we have to give a rounded answer for AP or pre-AP math, we always round it to 3 decimal places, so that's why I'm rounding it out to 3 decimal places here. So that would be the area of the circle. Now for class purposes, most of the time I'm going to ask you to give me the exact answer whenever possible. If it's not possible to give me an exact answer, then give me the approximate answer. Now in example B, they're giving us the area of the circle. We need to work backwards to find what's the diameter. So pi r squared for the area of the circle is going to be equal to 201 because that's what's given to us. Divide both sides by pi, so we get 201 over pi. And of course here, we're going to wind up taking the square root of both sides, so that way we can get the radius. So the square root of 201 over pi is going to be really, really close to 8 inches. It's like 8.001 something. So here we're going to say that the radius is about 8 inches, so that means that the diameter is really close to 16 inches. So moving on here, now we're going to be talking about how we find the area of the sector of a circle. Now this is only a part of the circle. So the part that we're going to be looking for is obviously going to be proportional to the part of the, if we look at the ratio of the part of the circle that we're looking for to the total area of the circle, and we look at the ratio of the central angle of the sector and the total number of degrees in a circle, we wind up with this proportion that they're kind of giving us here at the top, and the way that I have it written here. Now, if you've seen the video lesson over arc length and how we find the length of an arc when we know the circumference of a circle, you've seen me use a proportion similar to this. So this is the way that I am always going to work out the problems whenever I have to do it or whenever I have to demonstrate how to do it, simply because the proportion is a versatile tool, because I can find the area of a sector, I can find the area of a circle, I could find the central angle, or I could even find what the radius is. So the proportion is going to be my modus operandi for whenever I'm having to find the sector of a circle, the area of a sector, or the area of a circle if I'm given the area of a sector. So here in this example, what it's asking us to do is find the area of the sectors that are formed. Now again, keep in mind, anytime you create one sector of a circle, it's naturally going to be divided up into 2 regions. The region of the minor sector, and what's left over is the major sector. So we want to find the measurement of, or the area of, both the shaded and the unshaded sectors in circle Q in the diagram. Now in the first one, we have to identify some things here real quick before we go. Of course, the measurement of the central angle, angle RQS, that's the measurement of the arc, so they're the same thing. That's why in the proportion I just used the central angle. And so the measurement of the major arc, or the reflex angle, would be 297 degrees. So here we want to go ahead and find what is the measurement, what is the area of the small sector. So here we have it set up as nicely, because the common way of looking at it, if you were to Google what is the area of a sector, it's really going to kind of give you this a lot of times. It's just going to give you that instead of the proportion that I obviously prefer to use. But substituting the values here, we know that the central angle is 63 degrees. The radius is 5, so we say 63 over 360 times pi times the radius squared. Now, the exact answer is the 4.37 pi units squared. And we don't know the units. We don't know if it's inches or centimeters or whatever, so you just generically use UN to abbreviate for units squared in this case. So that's the exact answer. The approximate answer would be, take it off my pen here, that multiplied by pi, so about 13.7 units squared. Now the area of the larger sector here is going to be found basically the same way, but instead of using the minor arc of 63 degrees, we're going to use a major arc, or the reflex angle. Remember, a reflex angle is an angle that's larger than 180 degrees, but less than 360. And we basically do the same thing. We wind up with the exact answer for the major sector to be 20.625 pi units squared is the exact answer, or about 65 units for the approximate answer. And so those are the two kind of values that we're looking for. Now again, keep in mind, classroom purposes, I'm most likely going to be asking you to give me exact answers whenever possible, rounded answers if necessary. So at this point, ladies and gentlemen, go ahead and pause the video and answer the 3 questions that we have here. And when you're done, hit play and come back and listen to the explanation and check the answers that I have. Okay, so hopefully we have some good answers. The first one, simply find the area of the circle. Now here, when we work this one out, the 9, maybe that's the radius, maybe that's the diameter. It's kind of hard to tell. If you did 9 as the radius, I get it, it's okay. But 9 is actually the diameter, so we take half of that and square it. So the area, as the exact answer, 20.25 pi, or as an approximate answer, 63.617. The next one, find the radius given the area. So here, divide the area by pi and take the square root of both sides. So I guess if you want to get technical, maybe 150 square root of 154 over pi is probably about as close as an exact answer as you could get, but again, we don't really like to have pi in the bottom of a fraction because it's an irrational number, so the approximate answer is really, really close to 7 feet. Now the last one here, find the area of the sectors, find the area of the major sector and the minor sector. So here I went ahead and I'm going to work this out here using the proportion that we have. So the minor sector, I'm calling that x. And so I'm going to substitute the values, simplify the fraction, and then just cross multiply. So the exact area of the minor sector is 23.85 pi feet squared. And the area of the major sector, when you work that one out, is 57.15 pi feet squared. Of course, the approximate answers are also given to you, but that's how we're going to use the proportion to find the area of the sectors. Now, one of the things I really like about that proportion is, again, we could use it to find the area of the sectors like we did here. We could use it to find the measurement of the central angle if that's not given to us, or we could use it to find the area of the circle. But I really, really like the questions when it says it'll give you all of this stuff, and instead it'll ask you, what's the radius? So the proportion is really helpful when we work that stuff out, because you'd have to do all that stuff, isolate the radius, and then take the square root of your value in order to get what the radius is. So here, again, we're going to kind of use that sector area formula. So that way, in this case, it's asking us to find the area of the sector, so or the area of the entire circle. Now here, I really am not a big fan of how they set up the problem. It's really just kind of cut and dry. They're not giving you a whole bunch of stuff here. They're not even really giving you the step-by-step things. So taking the information that we have, they give us a ratio of 45 degrees to 360, but they're not really showing us how we're getting the area of 176. They're not showing that we either divide by the fraction or we multiply by the reciprocal of the fraction, and we could even simplify the fraction. So here I kind of worked it out using the proportion that I prefer to use. So substituting the values, 22 for the sector area that was provided for us, 45 over 360. I didn't simplify the fraction 45 and 360. I just went ahead and did cross multiplication, and I wound up dividing the 7920 by 45. But that's how I would work it out. If I was just given the problem, I always use that proportion, 176 meters squared for the area. Now again, if I know the area of that circle, I might have to go through that work, and then I could say, well, what would be the radius? What if I asked you what was the radius? Well, we would do that proportion, we would do all of this work, then I would take the 176 and I would say that's equal to pi times the radius squared, and then I would say that would be 176 divided by pi, the square root of that is equal to the radius. So we could go that far with using this information. Now here, this is kind of an application kind of question, and I really like questions like these, and I'm a big fan of how they actually set it up, because this is what I actually do all the time when I have to find the area of a composite shape. And that's exactly what we have here. We have a rectangle where a square and a semicircle has been removed, and it's asking us to the nearest square inch, what is the shaded area? What's the wood that's left over? So the way that we're going to do this is we're going to find the area of the overall rectangle and then subtract the area of a semicircle and the area of a square. Now here, this is how I actually started off. I say the area is going to be equal to the area of the rectangle, which is base times height, use the formula, minus the semicircle, so that's half of a circle, half times pi times radius squared, and the area of a square, side squared. Now I'll go and I'll substitute my values. So base times height for the rectangle, 11 and 7. Pi times radius squared will give me pi times 1.5 squared. And the area of the square is 3 squared. Simplifying those values here will give me 1.125 when I square the radius. 9 is what I get when I square 3. And when I simplify the like terms, the 77 and the 9, those are like terms. So if I say 77 minus a positive 9, that's just saying 77 minus 9. So the exact answer is 68 minus 1.125 pi inches squared. And that's exactly how we write it, because pi is multiplied to 1.125, but it's not to the 68, so they're not like terms. So that is exactly how you write the answer in terms of pi. Now, if I wanted the approximate area, like it's asking, what is the approximate area? In this case, 64.466. So if you really round that up, that's probably closest to about 65 square inches. So moving on, let's go ahead and have you guys again pause the video at this point, find the area of the circle, find the area of the composite shape. When you have your answers, go ahead and hit play again and come back and listen to my explanation and check my answers with what you got and see how you did. So go ahead and pause the video now and come back when you're ready. All right, so hopefully by now you have the area of the circle. Again, they're giving me the area of the sector, so I'm going to use the sector area formula, the proportion that I have, that I showed you I would use. So sector area over pi r squared is equal to the central angle divided by 360. So substituting the values, they gave me the sector area to be 6.4, the central angle is 80 degrees, and the 360 is given in every circle. Cross multiply and divide, and we get 28.8 yards squared for the area of the circle. Now moving on, find the area of the composite shape. We have a triangle and we're adding a semicircle to it. So that's how I set it up. I say I have a triangle plus a semicircle. Substitute the formula for both of those areas. Triangle is 1/2 times the base times the height. Semicircle is 1/2 times pi r squared. Substitute their values, and then as an exact answer for the shaded area, I get 14 plus 6.125 pi feet squared. And as a rounded approximate answer, 33.242. So that's going to about wrap it up here for us in this lesson. Finding the area of the circle. The area of the circle is just kind of another derived formula based really on a parallelogram or a rectangle. So area of a circle is just pi times the radius squared. The way that we find the sector area is as a proportion to the piece that we're looking for of the sector to the entire circle, and the part that we know for the central angle versus the total 360. So sector area over the area is equal to the central angle over 360. But that's about it for this lesson. If there's any questions that you have about anything that you see, or maybe I just didn't explain something well enough for you to understand it completely, by all means, guys, please let me know. Shoot me an email, drop by my class, see how I can best answer your questions. But until next time, ladies and gentlemen, thanks for watching and take care.